In this worksheet, I'm going to talk about the balancing equations worksheet 1, which is synthesis and decomposition. Now, as you might know that before, all right, synthesis and decomposition, they're basically the same thing, but they're just opposite. So the way to do balance equation for synthesis and decomposition are the same thing, because just like product and reactant, they flip. So it's the same way, okay? So I have some notes here. Okay, so how do you know that you're doing this worksheet correctly without asking me is you want to check if the number of the atoms on both sides of the equation are equal by drawing the competing the atomic table. So you draw the atom table with left and right, and then you put all your atoms on the bottom, and then you compare left and right for each atom. So how do you know they balance? If they are the equal numbers on both sides, then you know that the equation is balanced. So the notes here is number one, how do you find the total number of atoms will be you taking coefficient times subscript. So for example, if I have 5H2, the total number of H will be 5 times 2 is 10H. If I have 5 water, because water like is a compound, so you cannot just say 5 times 2 is 10 hydrogen and then only 1 oxygen. You can't do it because the 5 is a coefficient go to the whole molecule. So you have to put a bracket, and then you can say 5 times 1 is 5 oxygen. And if all the atoms are the same kind of atoms together on the same side, you have to add them all up. So for example, on the left-hand side of the arrow, I have 2 kinds of oxygen. Here is 2, here is 2. So we add them up, we say that we have totally 4 oxygen on the left. And right-hand side will be only 1 oxygen. But you cannot add the right side oxygen to the left-hand oxygen because they are not on the same side. You can only add on the same side if they're on the same side. And never change the subscript, okay? So for example, if I have H2O2 and then I have H2O, you cannot balance the equation by changing the oxygen from subscript 1 to 2. You can't do it, okay? Because you're changing the whole compound. And the coefficient must be a whole number, no fraction, no decimal, just a whole number. And then you put the coefficient in front of the compound with the bracket around. So for example, if you say KCl, you have 2 of them, you have to put bracket in front and you say you have 2 KCl, so that would be 2K and 2Cl. If you have Na2SO4, you say you have 2 of them, you have to put 2 and bracket, so then you will calculate you have 4 and 8, 2S, and then 8O. And you don't put the 1 as the coefficient until the whole equation is balanced. So you don't want to start with the 1. You want to put the 1 at last. How do you know you put the 1 at last? It's like when the whole equation is balanced by checking the atomic table. So do not do the 1 at the beginning. You put the 1 at last when everything's checked. And always checking to see if the coefficient is simplified. For example, if your coefficient are 2, 4, 2, 2, for example, it's not reduced. Okay, you think too much, you think too beyond, you multiply a big number, so then you make the coefficients too big. So if they can be simplified, you have to simplify. For example, divided by 2, divided by 3, to make the final coefficient the most reduced form. So at first, I'm going to ask you to put like in the order of the pen. So I'm showing the steps. I'm afraid that you will confuse about the step. So I will say step 1, I will do blue pen, step 2, green pen, step 3, red pen, step 4, black pen. And then if you have more than 4 steps, you go back to do the color. All right. So you will put the equal sign on each of the arrow, on the top of the arrow, and you put the equal sign in between left and right. And then when you start to draw the table, you can just put A, L, and R instead of atom, left and right. So the front is synthesis, the bottom is decomposition, and then the back is mix, but same thing. They do the same thing. So on the bottom, you're going to start to draw your own table by putting A, L, and R. Okay? So I'm going to start to do the questions now. All right? So we draw the table, and then we say we put the equal sign, okay, on the top of the arrow, and also put the equal sign here, so they're matching. So we have 2 kinds of the atom. We have Ca. We also have O. Okay, so if you match the equal sign on the left of the equal sign, I have 1 Ca. On the right, I have 1 Ca. So 1 and 1. This is blue pen, okay? And then on the, if you look at the arrow sign, the left, I have 2 oxygen. and then I have 1 oxygen. So if you're looking at this, Ca is balanced. How do I know Ca is balanced? Because they have equal number of Ca on both sides. But O is not balanced. So here on the left-hand side, I have 2 oxygen. Here on the right-hand side, I have 1 oxygen. How can I make the oxygen balance? Again, your coefficient must be like 1, 2, 3, 4, 5. You cannot make decimal. You cannot make division. So you can only multiply number. So how do you make the oxygen happy? Is multiplied by 2 to CaO on the right-hand side. So because this is a green pen, now because this is a compound, when you put the 2, you have to put a bracket to indicate that this is the whole thing. Now when you put the 2 onto CaO, you're not just changing the O, you're also changing the Ca because CaO is a whole compound. So when you put the 2 in the front, you have to change everything on the right hand side for CaO. So the Ca is no longer 2 on the right, the Ca is 2. The O also 2. Then now you make the oxygen balance, but your Ca is not balanced. Your Ca is 1 on the left and 2 on the right. So how can you make the calcium balance? We're going to go to the red pen, and I'm going to make the left hand side the Ca with 2. And here I don't need to put bracket because this is only an element, it's only one thing. So I'm going to put Ca2, so then I make this 1 to become 2. Okay. So again, I'm going to put the atom A, left, and then right. Okay, so when you start to draw your own table, you can just make it ALR. So then now you double check, okay? Is calcium 2 and 2 happy? Yes. Put a check mark at the end. I need to see a check mark because it's telling me that you check your you check your atomic table. And oxygen is also 2 and 2, we check. So basically this is balanced. But we also have one thing we did not put is the coefficient O2. So we go back here. We don't put the 1 as coefficient until the whole equation is balanced by checking atomic table. So here is balanced, then I can put the 1 on the O2 to make it balanced. Okay, and now you can see 2, 1, 2, the coefficient are the most reduced one because we cannot divide anything number other than 1. So this is the answer. Again, you always check the coefficient, are they in the most reduced form? Now here, this question, I have N and H. Okay, so we put the equal sign. Okay, so on the left, I have 2 nitrogen. On the right, I have 1 nitrogen. On the left, I have 2 hydrogen. On the right, I have 3 hydrogen. Now, none of them is balanced. None of them is balanced. So what do you want to start with? I'm going to show you both ways. I'm going to show one question here. I'm going to show another question. So here, let's say I want to start with 2 and 3. I want to start with hydrogen. I want to start with 2 and 3 because 2 and 3 is a special thing I can talk. Now, 2 is an even number. And 3 is an odd number. 1 is even, 1 is odd. So I think when your math teacher teaches you how to find the common multiple for even and odd, he will ask you to multiply the 2 and 3 together. So 2 times 3 will be 6. That means I want to make 6 hydrogen and 6 hydrogen on right and left. So here, on the left-hand side, I want to make 6 hydrogen, right? Because we say 2 times 3 is 6. So how can I make from 2 to 6? I'll have to multiply by 3. Okay? So make the left-hand side hydrogen is 3 times 2 is 6. Okay? And then red pen. On the right-hand side, I also want to make the hydrogen 6. So now it's 3, so how can I make it 6? I multiply this by 2 and put a bracket because this is a compound. Now, when I put the 2 in there, I'm not just changing the hydrogen, I'm changing the whole thing. I'm changing the nitrogen. Instead of 1, I make it 2. And I'm changing the nitrogen, I'm changing the hydrogen from 3 to 6. 2 times 3 is 6. Okay, now you go back to check. Is my nitrogen balanced? Yes. Is my hydrogen balanced? Yes. So then finally the whole thing's balanced. Then I can put the leftover coefficient with 1 in black pen. Okay, and again 1, 3, 2 is reduced, is most reduced. Okay, now let's go to number 3. Number 3, I have Al and O. Okay, so I got 1 Al, 2 Al, I got 2 O and 3 oxygen. Now this is another case of none of them is balanced. So on question 2, I show you start with 2 and 3. Now here I'm showing you start with the other one, 1 and 2. Okay, so Al is not balanced, okay, because I have one Al and two Al. So how can I make this Al happy? I times this 2 to Al. So green pen, I times this 2 to Al, so make the Al 2. Okay, now I can jump to the 2 and 3. Again, 2 and 3, one is even, one is often. We want to find the common multiple. We multiply 2 and 3 together. 2 times 3 is 6. So I want to make 6 oxygen and 6 oxygen. So here, how can I make 6 oxygen? Is I make the 3 here, multiply by 3 to make it, okay? So make it 6 oxygen. And then black pen, well, I want to make 6 oxygen. So how can I make this 6 oxygen from 3? I multiply the whole thing by 2. So black pen and bracket. Now again, I'm not just changing oxygen, I'm changing the whole thing. So Al, I change that from 2 to 4, black pen. And then the oxygen, I'm changing from 3 to 6. Now be careful. You change something. You look it up. Is Al happy? No. Al is not happy, but oxygen is happy. So how can I make the Al happy? Is I'm going to change the number 2 here from the 2 to become 4. Okay, it's okay that you go back to change your coefficient. That's fine. That's totally fine. Okay, you can go back to change it. Now we can say Al is 4 and 4, check. I need to see the check mark to make sure that I know you double check. And oxygen is 6 and 6, check. And that's the answer. And 4, 3, 2 are the most reduced. Okay, so let's say number 6 here. Okay, number 6. So number 6, I have I'm going to put an equal sign. I'm going to put the equal sign there so you know what I'm doing. Okay, so I'm going to put the equal sign back there. So I have hydrogen and oxygen. So on the left, I have 2 hydrogen. On the right, I have 2 hydrogen. Now for the oxygen, you have to be careful. This is like a special case. Oxygen, I have totally 3 because they are the same atoms on the same side. I have to add them. But how do I go with 3? Because I have 1 oxygen and 2 oxygen here. But instead of doing, say, 3, I want you to write them separately. I want you to write 1 plus 2. I want you to write 1 plus 2. And I'll show you later how's good on that, okay? I want you to separate them, 1 plus 2. And then on the right-hand side, I have 2 oxygen, okay? So now we can say the hydrogen is happy. Now the oxygen is not happy. Now this is not the same thing as this because this 3 come from every one compound, 2 and 3. These 3 come from one thing. But this 3, 1 plus 2, 3, is not coming from one thing. It's coming from 2 separate things. Okay, so how can I solve it? Now, O is a diatomic element. O is a diatomic element. So diatomic element meaning you always have 2. You always have 2. It hates to see odd number. It does not want to see odd number. Now, this is a even. This is a even, so it's good. Right? Oxygen 2 and 2 is good. But this one is an odd number. Now, remember oxygen is diatomic. It does not like odd number, it like 2. How can I make this 1 to be 2? How can I make this oxygen from 1 to 2? Is I'm going to multiply 2 to the water for this one only. Okay, so I'm going to make this 2 bracket. Okay, so I'm going to change the whole thing for the hydrogen and the oxygen on the number 1 only. I'm not touching this 2 for oxygen. Okay, so the hydrogen, I will get, instead of 2, I will get 4. And then this oxygen, instead of 1, I will get 2. Again, I'm only changing the left-hand side. I'm only changing the 1 from water. I'm not touching the oxygen. Okay, now you can see, okay, my hydrogen is 4 on left, but 2 on right. And oxygen is 4 on left and 2 on right. So how can I make the hydrogen and oxygen happy? Is I'm going to put the 2 in front of H2O2 on right hand side using red pen and bracket. Okay, so then now I make my hydrogen instead of 2 will be 2 times 2 is 4. And then I make my oxygen is before 2, and now 2 times 2 is 4. Now look back. Hydrogen 4 and 4 balance. Okay, my oxygen 2 plus 2 is 4. This is also 4. Okay, 2 plus 2 is 4. This is also 4. So oxygen is not also happy. Now you see that the difference between this weight and that weight is this 3 coming from one thing. This 3 coming from one thing. So we just multiply 2 times 3 together to get 6. But this one you don't want to write 3. You want to write separately 1 and 2. And then you want to take care of the one that is not 2. You want to take care of the one is only 1. You want to take care of the one like the odd number to be even. Okay, because diatomic like even. So then now it's balanced. So finally, I'm going to put the 1 on the O2. Again, you don't want to put the 1 until this table is balanced with the check mark. Then you put the 1. And then you can see the final answer is 212, which is the most reduced form. Okay. I think the rest of them, if you start to do the decomposition, you got to draw your own table. Okay, you draw your own table, but instead of atom left and right, you can just write A, L, and R, and then you have more atoms. You just add on the table. It's just extended.